Hi students, here I am explaining about real numbers. Quick recap. In class 9th we learned about real numbers and irrational numbers. This chapter focuses on two important properties of positive integers. One is Euclid's division algorithm. The two is the fundamental theorem of arithmetic. Shortcut we can call FTA. We will use the FTA for two main applications: proving the irrationality of numbers like root 2, root 3, etc., exploring the decimal expansions of rational numbers. The fundamental theorem of arithmetic. Basic idea: any natural number can be written as a product of its prime factors. Examples: 4 can be written as 2 into 2. 253 can be written as 11 into 23. This leads to a key idea: every composite number can be written as the product of powers of primes. Suppose 32,760. You can see 32,760. 2 into 16,380. Again 16,380 can be written as 2 into 8,190. Again 8,190 can be written as 2 into 4,095. 4,095 can be written as 3 into 1,365. 1,365 can be written as 3 into 455. 455, 5 into 91 we can write. 91, 7 into 13. So totally 32,760 can be written as 2 cubed into 3 square into 5 into 7 into 13. Next, Theorem 1.1, Fundamental Theorem of Arithmetic. Every composite number can be expressed or factorized as a product of primes, and this factorization is unique. Apart from the order in which the prime factors occur, uniqueness means 2 into 3 into 5 into 7 is the same as 3 into 5 into 7 into 2. The set of prime factors is one of a kind. To make the factorization truly unique, we write the primes as primes in ascending order. Application of FTA. Example: consider the number 4 power n, where n is a natural number. Check whether there is any value of n for which 4 power n ends with the digit 0. If a number ends in 0, it must be divisible by 5. This means the prime factorization of 4 power n must contain the prime 5. Let's check. 4 power n. So we can write 2 square whole power n, that is equals to 2 power 2n. And you know the formula: a power m whole power n is equals to a power m into n. So in that way we have written 2 square whole power n equal to 2 power 2n. The only prime in the factorization of 4 power n is 2. The uniqueness of the FTA guarantees there are no other primes in the factorization. There is no natural number n for which 4 power n ends with the digit 0. Finding HCF and LCM using prime factorization. Example: find the HCF and LCM of 6 and 20. HCF means highest common factor, LCM means least common factor, common multiple. 6 can be written as 2 power 1 into 3 power 1. 20 equals to 2 square into 5 power 1. HCF, product of the smallest power of each common prime factor. HCF of 6, 20 equal to 2 power 1, that is equals to 2. LCM, product of the greatest power of each prime factor involved in the numbers. LCM of 6, 20 equals to 2 square into 3 power 1 into 5 power 1, that is equals to 60. HCF uses smallest common powers and LCM uses greatest powers of all factors. Important property for two integers. For any two positive integers a and b, HCF of a, b into LCM of a, b equals to a into b. Example, find the HCF of 96 and 404. Then find their LCM. 96 equal to 2 power 5 into 3 and 404 equal to 2 square into 101. HCF of 96, 404 equal to 2 square, which is equal to 4. Using the formula LCM equal to 96 into 404 by 4. So, if you simplify that, you will get 9696. That means LCM of 96, 404 equal to 9696. Next, HCF and LCM for 3 integers. Example, find HCF and LCM of 6, 72 and 120. 6 equal to 2 power 1 into 3 power 1. 72 equal to 2 cubed into 3 square. 120 equal to 2 cubed into 3 into 5. HCF, smallest common powers, that is equals to 2 power 1 into 3 power 1, that is equal to 6. LCM, greatest powers of all factors. 2 cubed into 3 square into 5 power 1, which is 360. See, here the property only works for two numbers, HCF into LCM. Doesn't equal to A into B into C. So next, revisiting irrational numbers. A number S is irrational if it cannot be written in the form P by Q, where P and Q are integers and Q is not equals to 0. Examples, root 2, root 3, root 15, pi, 0.10110110 dash dash. Our goal is to prove that numbers like root 2 are irrational. And here technique we will use a method called proof by contradiction. Theorem 1.2, key for our proofs. Let P be a prime number. If P divides A square, then P divides A, where A is a positive integer. Proof idea, simplified one. The prime factorization of A is P1 into P2 into dash dash into P suffix n. So, A square equal to P1 whole square into P2 whole square into dash dash Pn whole square. If A prime P divides A square, then by the FTA, P must be one of the prime factors P1, P2 dash dash. Since P is one of the factors of A, then P divides A. Theorem 1.3. Proof that root 2 is irrational. Proof by contradiction. Assume the opposite. Let's assume root 2 is rational. So we can write root 2 equal to A by B, where A and B are integers. B is not equals to 0. Crucial assumption, A and B are co-prime. Co-prime means no common factors other than 1. Next, rearrange and square. That means B root 2 equal to A. Squaring both sides gives 2B square equal to A square. Now apply theorem 1.2. The equation 2B square equal to A square shows that 2 divides A square. Therefore, by theorem 1.2, 2 divides A. Step 4. Substitute. Since 2 divides A, we can write A equal to 2C for some integers C. Substitute this into 2B square equal to A square. 2B square equal to 2C whole square, which simplifies to 2B square equal to 4C square, and then B square equal to 2C square. Apply theorem 1.2 again. The equation B square equal to 2C square shows that 2 divides B square. Therefore, by theorem 1.2, 2 divides B. The contradiction from step 3, 2 divides A. From step 5, 2 divides B. This means A and B have a common factor of 2. This contradicts our initial assumption that A and B are co-prime. Conclusion, our assumption was wrong. Therefore, root 2 is irrational. Next, proving combinations are irrational. Example 6. Show that 5 minus root 3 is irrational. Assume it's rational. Let 5 minus root 3 equal to a by b, where a and b are co-prime integers. B is not equals to 0. Isolate the irrational part. Rearrange gives 5 minus a by b equals to root 3. So 5b minus a divided by b equals to root 3. The contradiction, since a and b are integers, 5b minus a divided by b is a rational number. This would mean that root 3 is rational. But we know that root 3 is irrational. This is a contradiction. Conclusion, our assumption was wrong. 5 minus root 3 is irrational. Chapter 1 summary is fundamental theorem of arithmetic. Every composite number has a unique prime factorization. HCF, product of the smallest powers of common primes. LCM means product of the greatest powers of all primes. Key formula, HCF of a comma b into LCM of a comma b equals to a into b. For two numbers only, this formula applies. Theorem 1.2, if a prime p divides a square, then p divides a. Proof by contradiction, assume the opposite of what you want to prove. Then find a logical contradiction.